All right, let's take a look at number 11 on 4A. And it's asking, what's the value of 5 to the 7th over 5 to the 7th? Well, it's just something divided by itself, so that's going to be 1. And a cubed over a cubed is also going to be 1. And c to the 12th over c to the 12th is almost always 1. There's only one exception to this, except when c is 0. And the reason for that is, well, as c 0, 0 to the 12th is still 0. So you would have 0 in the denominator, and it doesn't matter what's on top. Anytime you have 0 in the denominator, it's undefined. Right? So you just can't have 0 in the bottom. Even 0 over 0. Okay. Um, so let's see. So we learned a rule a while back that said a to the m times a to the n equals a to the m plus n. That was, I think, like number, what was it? Let's see here. Is that number 5 or something like that? Yeah, number 5 on your homework or on this handout says this rule. It's called the common base principle for multiplication. Um, well, you might think of it also as if I replace this with a negative n, then this becomes a minus n up here. So a to the m times a to the negative n equals a to the m minus n. Now there's also a rule that we have that says a to the negative 1 is 1 over a to the negative 2 is 1 over a squared. So a to the negative n is really 1 over a to the n. So this is a to the m times 1 over a to the n equals a to the m minus n. Right? Because these two things, this and this, are the same. Okay. Well, this is the same thing. This whole side now is the same as a to the m over a to the n. So it's kind of related to this rule in a sense. Really, they're versions of the same rule. It just depends on if n is positive or negative. If you're multiplying two numbers together and they have the same base but different powers, you can add the powers. If you're dividing two things and they have the same base but different powers, you can just subtract the powers. Right? So let's see here. If I wrote, 5 to the 7th over 5 to the 6th, you can jump to 5 to the 7 minus 6, or you can jump to this idea. It's 5 7 times divided by 5 6 times. So 6 of them cancel, and you're left with just 1, right? And that's where that subtraction idea comes in. So it says then, if you're doing something like 5 to the 7th over 5 to the 7th, that's like 5 to the 7 minus 7, which equals 5 to the 0. Now, 5 to the 7 over 5 to the 7 also equals 1. So now we've sort of set up something that says 5 to the 0 has to be 1. If we did it with the 8 cubed thing, 8 cubed over 8 cubed, and use that new rule that we have, that's 8 to the 0. But we also know 8 cubed over 8 cubed is 1. So 8 to the 0 equals 1. C to the 12th over c to the 12th equals c to the 12 minus 12. So c to the 0, which also equals 1, except in one case when c is 0. So in general, this right here is a true fact. We define anything to the 0 as 1, except when the anything that we're raising to the 0 is also 0. 0 to the 0 is undefined. There's no way to know what wins. Is it raising it to the 0 equals 1 wins, or 0 to the anything equals 0 wins? So you can't have both, so it's just undefined. Let's take a look down at the bottom here, number 12. Find equivalent ways to rewrite these things. So 6 over 3 is just 2. And then the a to the 8th over a to the 4th is a to the 8 minus 4 now. So 2a to the 4th. And if you wanted to kind of work that out, you could also think of it as 8 a's all multiplied together on top. 1, 3, 4, 5, 6, 7, 8 over 4 a's on the bottom. And so these 4 cancel with those 4, and you're left with 4, right? And then there was the 6 and the 3, which turned into the 2 right there. Okay, in B, we're doing 3p cubed, q to the 4th, all squared. So what you have to do is you got to think of it as it's 3p cubed, q to the 4th, times another 3p cubed, q to the 4th. And now we're not distributing anything. Everything's already being multiplied together. So at this point, it's like I didn't even have these parentheses here. And I just have a multiplication there. So 3 times 3 is 9. P cubed times p cubed. Well, I've got 3 p's and 3 more, so I have 6. And q to the 4th times q to the 4th is q to the 4 plus 4, so q to the 8. So here's that answer. You could also do it this way. You could think of it also as 3 squared, p cubed squared, q to the 4th squared, and then use the rules that we have. Well, that's just 9. This is p cubed squared, and we learned the new rule that said a to the m to the n is a to the m times n. So this would be p to the 6th, and this would be q to the 8th. Now you got to kind of keep track of these different rules that we have, because it's easy to get them confused, right? If you're ever in doubt, just sort of write it all out without worrying about the rules. Write it out like this, if that helps, right? Okay, now this one's a little bit uglier. B to the half, b to the 3rd, b to the 6th. So we know this idea right here. This is what it mimics, right? It's something to a power times something to a power, and then in this case, times something to another power. So we're going to tack on another plus something here. So this all turns into b to the 1/2 plus 1/3 plus 1/6. And if we work that out over here, we need a common denominator, which will be 6. So this one turns into 3/6. This one turns into 2/6. And this one is 1/6. So all that adds up to 3 plus 2 plus 1 is 6/6, which is 1. So this whole thing just turns into b to the 1st, which is b. And the next one, let's see, we've got 2x cubed squared over 3y squared squared. And so this is going to be 2x cubed squared over, well, actually, let me write it out this way. It's that fraction times itself. And then if we work that out, well, it's 2 times 2, which is 4. X cubed times x cubed, that's 3x's multiplied with another 3x's multiplied, so it's 6x's altogether. And then on the bottom, I got 9 and 2 y's and 2 more y's, so y to the 4th. And there we go. And then there's this last one, d to the 0.5 to the 6th. Well, that uses this idea up here, right? It's something to a power, all to another power. So then you multiply the powers. So this really just turns into d cubed. Now, d to the 0.5 is really d to the 1/2. And we learned back in number 5 that that's the same thing as root d. So if you think of d to the 0.5 to the 6th as root d to the 6th, well, then you can kind of think of it as, okay, it's root d, root d, root d, root d, root d, root d. There's a pair here, and a pair here. That's d times another d times another d. That's d cubed. Right? So you could get it a couple different ways.